Welcome to this deep dive into welfare economics. Today, we are exploring one of the most fundamental concepts in microeconomics, consumer surplus. Imagine you are walking down the street on a hot day and you see a stand selling cold lemonade. You are so thirsty that you'd be willing to pay $5 for a glass. However, the price on the sign says only $2. That $3 difference, the gap between what you were willing to pay and what you actually paid, is the essence of consumer surplus. To understand this mathematically, we first need to revisit the demand curve. In economic theory, the demand curve D of Q represents the maximum price consumers are willing to pay for each additional unit of a good. This is known as the willingness to pay, or WTP. According to the law of demand, as the quantity increases, the marginal utility of each additional unit usually decreases, causing the curve to slope downwards. We can represent this as a function P equals F of Q, where P is the price and Q is the quantity. Now, let's introduce the market equilibrium. In a competitive market, the price isn't determined by a single person's desire, but by the intersection of supply and demand. This intersection gives us the equilibrium price, P star, and the equilibrium quantity, Q star. Every consumer who is willing to pay more than P star gets a bargain. They pay the market price, but they receive a value that for them is much higher. This is where calculus becomes our most powerful tool. If we look at the demand curve, we can divide the area under it into tiny vertical rectangles. Each rectangle represents the value of a very small increment of the product. The width of each rectangle is dq, and the height is the price P at that point. If we sum all these rectangles from 0 to our equilibrium quantity Q star, we get the total value or total utility the consumers receive. However, consumers don't get this for free. They pay a total amount equal to the price times the quantity, which is the area of the rectangle formed by P star and Q star. To find the consumer surplus, we take the area under the demand curve and subtract the area of the expenditure. In terms of integrals, consumer surplus CS is the definite integral from 0 to Q star of the demand function D of Q minus the constant price P star. Mathematically, CS equals the integral from 0 to Q star of D of Q minus P star dQ. Let's look at a concrete example. Suppose the demand for a new smartphone is given by P equals 1,000 minus 0.1 Q squared. If the market price is settled at $640, we first find the equilibrium quantity by solving 640 equals 1,000 minus 0.1 Q squared, which gives us Q equals 60. By integrating the function 1,000 minus 0.1 Q squared minus 640 from 0 to 60, we find the total accumulated happiness or surplus of the buyers. This isn't just an abstract number. It represents the economic welfare generated by the market's existence. Why does this matter in the real world? Governments and organizations use consumer surplus to measure the impact of policies. For instance, when a tax is implemented, the price rises and the quantity sold drops. This shrinks the consumer surplus area, creating what economists call deadweight loss, a loss of economic efficiency that benefits no one. Conversely, when a company like Google or Meta offers free services, the consumer surplus is massive because the price is zero, even though the value to users is worth billions. In conclusion, consumer surplus is the bridge between market prices and human satisfaction. By using the power of integration, we can quantify the invisible benefits of trade and better understand the health of our economy. From the coffee you buy in the morning to the digital apps you use for free, calculus helps us measure the value of our choices. References: 1. Marshall A. 1890, Principles of Economics. 2. Varian H.R. 2014, Intermediate Microeconomics, A Modern Approach. 3. Stewart J. 2015, Calculus, Early Transcendentals. 4. Brian Fulson, E.O. 2012, The Attention Economy, Measuring the Value of Free Digital Services.